Physics, Part 88. What Newton is defined as the force which will give a mass of 1 kilogram and acceleration of 1 meter per second in the direction of the force. When a force is applied to a body, that force is always applied by another body. When you push a supermarket trolley, the trolley experiences a force. That force has been applied by another body, you. Newton understood that the body on which the force is exerted applies another force back on the body which is applying the force. The supermarket trolley exerts a force on you as well. The Newton's third law relates these two forces. Whenever one body exerts a force on another, the second exerts an equal and opposite force on the first. Very often this law is stated as, to every action there is an equal and opposite reaction. But this statement does not highlight the very important point that the action force and the reaction force act on different objects. To take the example of the supermarket trolley, the action force exerted by you on the trolley is equal and opposite to the reaction force exerted by the trolley on you. Newton's third law has application in every branch of everyday life. We walk because of this law. When you take a step forward, your foot presses against the ground. The ground then exerts an equal and opposite force on you. This is the force on you which propels you in your path. Space rockets work because of the law. To expel the exhaust gases from the rocket exerts a force on the gases. These gases exert an equal and opposite force on the rocket, sending it forward. Examples. Number 1, an object of mass 1.5 kilogram is to be accelerated at 2.2 meter per second. What force is required? By Newton's second law, F is equal to ma. 1.5 into 2.2 is equal to 3.3 newtons. A car of mass 1.5 tons, 1.5 into 10 power raised to 3 kilogram, traveling at 80 kilometers per hour is to be stopped in 11 seconds. What force is required? The acceleration of a car can be obtained from v is equal to u plus at. The initial speed is u is 80 kilometer per hour or 22 meter per second. The final speed is v is 0. Then a is equal to minus 22.11, which is equal to minus 2.0 meter per second. This is negative because the car is deaccelerating. By Newton's second law, F is equal to ma. 1.5 into 10 cubic into 2.0 is equal to 3.0 into 10 power raised to 3 newtons. Now it's your turn. A force of 5.0 N is applied to a body of a mass 3.0 kg. What is the acceleration of the body? A stone of mass 50 gram is accelerated from a catapult to a speed of 8.0 meter per second from the rest over a distance of 30 centimeters. What average force is applied by the rubber of the catapult? Weight. We saw in previous chapter that all objects released near the surface of the earth fall with the same acceleration of free fall. if air resistance can be neglected.